Haloform test. A type of haloform test is the iodoform test. Now there are many kinds of haloforms, but the iodoform, which is CHI3, it is a yellow crystalline solid, and in the presence of certain types of aldehydes, ketones, or some types of alcohols, it will give a yellow PPT of crystalline solid, and it will have a characteristic smell to it. It is an antiseptic used in hospitals. So what we'll see is it is only redundant in the chemical reactions that have aldehydes, ketones, and alcohols that have a alpha methyl group in them. Now the alpha methyl group can occur in aldehyde as an acetaldehyde, and an acetaldehyde only will it have. Now the alpha methyl group, what I mean by that is this is the main carbonyl carbon, and the carbon attached to it is alpha carbon. Now if we see that if we have an ethanol, if we have a propanol for example, we do not have an alpha methyl group. We have a methyl group which is on the beta carbon. So only acetaldehyde will give the iodoform test positive. Now in ketones, the alpha methyl group is present in basically this structure. Now this R group may be different, may be ketone, or may be metamerically different, for example C2H5 or CH3. Let's just stick to acetone for now. And for alcohols, 1 degree and 2 degree alcohol give, and not 3 degree. 1 degree alcohol, only ethanol will give that reaction, because what we have over here is the carbon bonded to the functional group alpha, the methyl group is bonded to alpha methyl, and then the 2 degree one, it will have an iso structure. So for example this, and anything can combine over here, any R. So, and then 3 degree will give negative for this reaction. Now the reactants that are involved in the reaction are first the aldehyde, ketone or alcohol, and then the iodine in the presence of an alkali, for example NaOH. Now one thing to note is that for aldehyde and ketones, this will be 3 moles, this will be 4 moles. That is just the basic part. So now let's test it out with propanone methyl ketone, which has the alpha methyl group. We'll do is we'll react it with 3 iodine and 4 NaOH. What will happen is this will react with iodine and it will form iodoform. The sodium will combine to one of these as well, and water will also form with the rest of that ketone. So what we'll have is sodium acetate. Now if we balance out the equation, we will see that 4 sodium are over here, 1 sodium here, 1 sodium here. So we will do 3 over here, and then for hydrogen we have 2 over here and 1 over here. So that's 3, and then we have 6 over here. So 6, that's 6 over here, and then 7 over here. So what we'll do is we actually have 3, 6 and 10 over here. So what we'll do is we can't change these 4. So what we'll do is we just multiply it by 3, and then we would have 6 hydrogen ions, 6 hydrogen over here, 4 over here, and then the same is the case with that one. So that's that. Moving forward, we will use acetaldehyde as an example. It's going to combine with what I said before, 3 iodine and 4 NaOH. It will also show positive. It will form this iodoform molecule, and it will form the same sort of byproducts, and then it will form a sodium formate molecule. We have ethanol over here. It will also react with the same reactants, and then it will form iodoform. This part will form the formate ion, and then we will also have the sodium iodide and water. But this is the balanced version of it. I added 4 over here, 6 over here, 5 over here, 5 over here. How is 5 2s are 10 and 11, 5 and 6 is 12 and 12. So 4 iodine, 4 2s are 8, 5 over here, 7, 8 over here, and then sodium 1 over here and 5